So 5.7, we are still talking about linear inequalities. But if you look at the I can graph systems of linear inequalities. So we knew what systems of equations were, right? Two equations put together. Systems of inequalities now are going to be that same thing. We're going to have two inequalities together. And we're going to find the system, the solution to the system. And just like with equations, if it's going to be a solution to the system of inequalities, it needs to work for both of them. So the first sort of thing that we're going to look at is with our system. So we're going to have two different inequalities here. We have two different inequalities, and then they're going to give us an ordered pair. They're going to say, is it a solution? All right, pretty straightforward. We've seen this type of question a bunch by this point. But let's say that we have, let's say 2, 3. Let's see if that is a solution. Remember, for it to be a solution, it's got to work for both, right? Not just one, it's got to work for both. So what do you think? Is 2, 3 a solution? Yes. I see some yes, I see some no. Let's double check. We plug it in, plug the 2 in for x, 3 in for y. 2 times 2 is 4. 4 is bigger than 3, so it works for the top. If we plug it in the bottom, I got 2 plus 1 is 3, and the 3 here. 3 is greater than 4 equal to 3. So yes, this one works. Yes, this is a solution. Okay. Let's try another one. Let's go 0, 0. 0, 0, of course, the easiest one to plug in. Zeros are always the best numbers to plug in. Is this one going to work? Yes or no? No, it's not. Right? It doesn't work in either of them. So it's not a solution. As soon as you find that it doesn't work for one of them, you don't even have to try the other. Right? We know that it's a no at that point. All right, so that's one type of question that you're going to see. Any questions on that? Pretty straightforward. Just pay attention to that sign, right? If you get 3 is equal, or 3 is greater than or equal to 3, that is a solution. But if you get 3 is greater than 3, it's not a solution, right? So just pay attention to the sign. All right. So now what we're going to do is we're going to graph them. We're going to graph the same system. Okay, so I want you to create a graph 5 in every direction. Go ahead on your page, 5 in every direction. All right, so we want the solution to this. And the solution is going to be any ordered pair that works for both of these. Just like yesterday, there's going to be an infinite number of solutions. Okay, so we have to represent on our graph where those solutions are going to take place. Very similar to yesterday. Everything that you need to know for today, you learned yesterday. Because all we're going to do is we're going to graph both of these, and we're going to graph them on the same coordinate plane. That's it. Okay. Let's do one at a time though. I want you to go ahead and graph that top one, just like we would yesterday. Y equals mx plus b, shade it, dash line versus solid line, all of that. So go ahead and graph just the top one, please. Just the top one for right now. If we're going to graph that top one, right, y equals mx plus b, what's my y-intercept? What's the y-intercept, Levi? 0. There's a plus 0 there, right? So that means my y-intercept is 0. I got to start at 0, 0. I got to start at that origin. If there's no y-intercept, it's 0. We got to have a point there. Then from there, we can use the slope. The slope is 2, so that's 2 over 1. Right? If we need to, then we can rewrite it like that with the plus 0 there. But you got to start at the right point, otherwise your graph's not going to make sense. So we got our intercept at 0, our slope is 2 over 1. So from that point, I'm going to go up 2 over 1. I'm going to do that a couple times. I'm going to go down 2, back 1 a couple times, right? I want the whole graph to be covered by this line. Is this line going to be dashed or is it going to be solid? Dashed. It's going to be a dashed line. So we're going to dash that line. And then is it going to be shaded above or below? Below. It's going to be shaded below, right? Y is less than, so it's going to be shaded below. Right? We can't think left and right. We have to think above and below. So Y is less than, so it's shaded below. So I'm going to shade that side of my graph. Okay, there's our first one. Make sure it's dashed. Make sure we're at the right intercept, the right slope. Right, we're kind of bringing a bunch of stuff together here. You still need to know how to graph y equals mx plus b. And if you don't, then it's going to be tough for you, quite honestly. Right? And judging by the quiz that you guys took, when it was here, graph these two equations, some of you weren't able to graph the equations. We have to be able to graph an equation by putting it into y equals mx plus b graph. All right, if you have another color, if you have a pen, you have a colored pencil, you have something else, grab that. It's going to be easier for us to visualize if you have another color. Okay, and then with that second color, let's graph the bottom one. Okay, now if you're using a pen, you better be careful and make sure that you're doing it right the first time, right? You got your intercept at 1. Your slope is 1 over 1, so up 1 over 1. Okay, go ahead and graph that bottom one. If you don't have another color, that's fine. Just use the same pencil, it's fine. Not a problem at all. Just sometimes it's easier to visualize if you do. All right, for that bottom one, we've got an intercept of 1. So I got an intercept at 1. My slope is 1 over 1. There's no number out in front. It's a 1, so 1 over 1. So from there, I'm going to go up 1 over 1. Okay, down 1, back 1. I'm going to make sure I've got that the whole way through the graph. It's going to be a solid line this time. Okay, so it's going to be a solid line through all of those points. And then I'm going to shade above. So I'm shading above. All right, so I'm shading above that line. So there's our graph, right? That is our graph of the solution. Where are our solutions located? What do you think? How am I going to know by looking at this graph where our solutions to this system are going to be? Eli?
Where they cross.
Where what crosses?
The 2 lines.
The 2 lines cross? Like so this point?
Yeah.
I will tell you this point is not a solution. Good idea, right? If it was a system of equations, then that would be the solution. Yeah.
Would it be in between them? Or
What do you mean in between?
like,
So I think you're on the right track, but
like in between like at the top, like in between the 2 lines.
here?
Yeah. That
Yeah, so our solutions are going to be the section where it's shaded with both colors. So where it's shaded with both colors, that's our solution. So it's shaded in between these 2 lines here, and these lines would extend, right? We would extend these lines. So anything, wow, that was terrible. So anything in between these 2 lines, that is my solution right there. Because that's where it's shaded twice. This is why we need to extend our graphs. This is why we want long graphs here. So that we can see where it's going to cross, where we have the doubly shaded section. Because that's where our solutions are going to be, is where it's shaded twice. Okay. All right, so again, just graphing them both as you would yesterday, and we're just seeing where do they cross, where do they both shade. That's our solution. Okay. Questions on that? Okay, now I told Eli that this point is not a solution. Why is this point not a solution? Justin? Exactly, because one of the lines is dotted. And that means any point on this dotted line is not a solution to this purple one. Okay? If it was solid, like this point right here, is this point a solution? This point is a solution. It's shaded with the purple, and it's on the solid red line. So it works for both. So if it's on a solid line, it's a solution. If it's shaded, it's a solution. It's a solution. If it's dotted, if it's on the dotted line, it's not a solution. Okay, so we got to be aware of that as well. Okay. All right. Let's take a look at another one here. And I'll have you do it on your own. I'll give you a few minutes to do it on your own, and then we'll check back in. All right. Make you work a little bit. Make sure you put in the y equals mx supposed to be first, right? Put in y equals mx supposed to be first, and then go ahead and graph both of these, please. Again, using different colors if you have. sure we're paying attention to dashed versus solid, right? Which way you're shading, above or below. Another few seconds here, I'll start drawing it up. All right, so for that top one, I add the 2x over, so I get y is less than 2x plus 4. So if I go to graph that, I've got my intercept at 4. My slope is 2, so that's up 2 over 1. I'm going to do it the other way as well, down 2, back 1. So I have a nice long line here. It is going to be dashed. So it's a dashed line. And y is less than that. So I'm shading below the graph, so I'm shading down here. Now, if you're using a pencil or something, you can shade, better than me. I just don't want to ruin my entire marker. So that's our graph of the first one. Then for the bottom one, I subtract the 2x over, so now I have y is greater than negative 2x plus 4. So again, I have an intercept of 4, but now I'm going down 2 over 1. I'm going down 2 over 1. Do that a few times. Right, go the other way a couple times. Again, it's dashed. And now I'm shading above that line. So I pick a point, I go above that line, it's over here. So that's what my graph is going to end up looking like. Raise your hand, give me an ordered pair that is a solution here. Give me an ordered pair that is a solution. Alec? 5, 5 is a solution. Absolutely. Okay. Levi? 3, 1 is a solution. A couple more. Eli? 4, 4. Solution. Take 4, 3. A solution. Is 100, 1 a solution? Yeah, 100, 1 is going to be way out here, right? That's still going to be doubly shaded over here. So it doesn't have to be where your exact shading is. Anything to this side now is going to be a solution. Okay, we got to remember that that's extended out forever. Okay. What about the point 0, 4? 0, 4, is that a solution? No, I see some people shaking no. Yeah, it's not a solution. Even though they both share it, right? They both have the same intercept. It's not a solution because of the signs. Because they're both dotted line, dashed lines, that's not a solution. Okay, good. Good. Questions on that? All right, so really that's what you're looking at today. Let me point out a couple things that you might run into though. Let's say that I graph my line, and let's say I have this shaded here, and I've got a parallel line, and it's shaded underneath. What does that mean in terms of my solution? There's no solution, right? If they don't cross, there's no solution. Okay, that's fine. You might see that same set of parallel lines though, and they're both less than or equal to. So we're shading both underneath. Now we have solutions, right? Now we have both of them are shaded underneath here. So all of this would be a solution down here. So parallel lines doesn't necessarily mean no solution anymore. It all depends on the size, okay? Even if it is no solution, you still got to graph it. Because tonight the answer is the graph. Okay, the graph represents our solution. So you still have to put it on a graph, even if it's gonna be no solution. Okay.
What if the lines were like on the same line?
The same exact line?
Yeah.
Yeah, so if it's the same exact line, you still gotta look at the signs, right? Because if one sign is shading above and the other is, let's say it's dashed and shading below, there's still no solution, right? Because nothing crosses. If both signs are greater than, well then everything up there is a solution. Right? Yeah, that's a good question. Anything else? Any other questions that you guys can think of? Okay, just a reminder, y and a number, we talked about it in the warm-up, y and a number are horizontal lines. So this would be a horizontal line at 3 dashed and underneath. Okay, Levi?
Would there be any situations where there's all real numbers?
There's all real numbers. No, because you are either shading one half or the other half, right? So there's no situation where you're going to shade the entire thing. Yeah. Any other questions?